Well, hello everyone, and today we have a really interesting question. Let me read this first. Astronomer Ivan noticed that there is a group of stars, X1 to X12, which forms a perfect dodecahedron around the Earth. He went outside to observe some of these stars, and at a particular moment in time, he computed the angle. So del Z, we have a max function right here, and these are the five closest stars as you can see, which Z is the zenith at A1, A2 to A5, which belong to 1 to 12 because there are 12 stars and he's looking at five closest stars at a time, so in angular distance to Z. So let me, and we have to compute the minimum possible value of del Z that could have occurred. So del Z is not declination. So for the minimum value to occur, the zenith needs to be at the center. Because if it was any away from the center, for example, right here, then the case would be that it is just we will have a longer length right here and we will have a shorter length right here, and it will, the max function would obviously be max, but what we're asked is we have to find the minimum possible value of del Z, right? So considering Z is at the center, now we have to kind of make some figures. So this is, so suppose we have our celestial sphere right here, and we just have a pentagonal face just right here. So let's just have the zenith around in here, right? And it's just this pentagonal face, it goes just inside it. It's just that I can't show this in 3D. So let's just find the angle all right here, because we have to find this minimum possible value of del Z, right? Because we have to find the minimum possible value of del Z, which is I suppose it's the the angle basically. So first of all, what we directly see is a regular pentagon, right? Regular pentagon. Therefore, pentagon of course has five faces, right? And this whole, if you go from here to here, I want you to think that it has just roll around 360 degrees. If you can think of it, I want you to do this actual question before before really like seeing me do the question. So there are five of these arcs, so they will equally divide to be, I guess, 360 divided by 5, and we get here exactly 72 degrees. So I want you to think of the other. Let's have this one section right here, let's have this section right here directly into here. So we have the angle which is 72 degree. So what do we need? So what we need is basically the minimum value of del Z basically, right? So we are just going to find the value of, let's say, maybe b. Okay, so now what we're going to do is find this angle. So similarly, what we do is that, let me show you this. These are the faces, dodecahedron of course, and these are symmetrical, one face, other face, that's symmetrical. This will be, these all will be just spanning around 360 degrees, and since they are equally symmetrical and spaced, I guess, yep, it's like 360 degrees, and they will divide equally to become the angle 360 divided by 3, which is 120 degrees. So now that we have got wait, It's basically the zenith, no problem, no question right here. Now that we have got 120 degrees right here, it basically, when we just do this right here, it basically bisects it. So if this is 120 degree, it is going to be 60 degrees, and it is going to be 60 degrees, because for a fact we know these faces are symmetrical, and we'll need to have just the bisected angles, because this is a perfect regular dodecahedron, right? So yep, we have got this as 60 degrees. I hope I was able to make this clear. If I was not clear, then please write in comment section what will be more clear statement to consider it as 60 degrees, because it is kind of the place where people get confusing, because people can say they are not in the same plane, so it has to be like 108 degrees because it's the internal angle of a pentagon and blah blah blah. So yep, I would love to see some clearer statement for this as well. Now it's basically, we know that ZB is going to be equal to ZC, right? So let us consider that a K. So now we're going to find the minimum possible angle of cos through the zenith, of course, because it is from zenith to x. Yep. So basically what we're doing is, here's a star x, right, and x star, and we're going to find this minimum possible angle, this or this, whatever. So we're going to find this, we're going to find either b or c. There's no problem in there, so just let's use the sine and cosine law. So let this thought out, which is bc, yeah, let this be like, I don't know, bc, let this be small z. Fine. So what we have right here, okay, like what we have right here is, we need to find the cosine, we need to get the cosine law in here, and we need to get the sine law in here, and a lot of things. So let's get to the spherical cosine law. So with that, we are plugging in the spherical sine law as well, and we're going to do the thing. So what does the spherical sine law says? What does it say? So we have cos A equals cos B cos C plus sine B sine C cos A, right? So now what we're going to do is just put in the values. So let us consider for your easiness that it is cos z. I'm sorry for this confusion or whatever. It's going to be cos b cos c plus sine b sine c cos 72, right? So since these are same, I'm just going to write it just right here. We have cos z equals cos square k, because we consider it a k, okay, fine, plus sine square k cos 72, fine. Now also use the spherical sine law, and from the sine law we will get that sine c by sine 60 is going to be sine this I don't know, sine z by, what do we have here? Yep, sine 72. So we have sine z, right? We're going to find the z as, you know, what's the sine c? 60, right? Sine, I mean, yeah, so sine 72 by sine 60 times sine of c, basically, yep, sine of c. Yeah. So um, so just solve these two equations. When you solve these two equations, would this be equation I guess equation what equation equation I what do we have in common here? So basically what we have been saying, zb equals z, so this is a k, so this is just k and nothing. So we have k right here and we have cos z right here, exactly two variables. We have two variables, two equations, and on solving these equations you will get the this magical c, which we are going to find as let me just put it directly on the calculator, I guess. I don't know. Yeah, I think when I did it earlier the day, c, or what we call the k, will come as 37.38 degrees, which is exactly what we are trying to find. We are trying to find this whatever, this is the smallest angle that could ever be possible and the group of the largest angle. So del z minimum is going to be nothing, that is 37.3 degrees. It was the overall answer for that, and I would love to hear your voice about how it is 60 degrees, because it's really interesting one, and people consider it's not the same plane and whatever, but I'm trying to tell them that it is in the sphere and it's just different, and you need to twist your genius brain a bit. I would love to hear about your statements, because I feel like I didn't make it clear a bit, or hope it was clear to you. That's it. This was an interesting question, and yeah, I'll be making more videos about this. Thank you.